Okay, alright, so we have graphs of the secant and cosecant function. This is trigonometry, everyone's favorite class.
Yay!
Yeah, alright. Okay. Yes, I am recording. Okay, excuse me. Thank you, Rocha. Alright, so we're going to graph this. So now, if you guys paid attention in section 4.2, all the steps are the same. Okay? On 4.3, do you guys remember how many steps there were? 7. Okay, but back in 4.2, there was only 6. There's only 6. Because after we did our parts, and then we went to graph. So there's one less, but this one is actually exactly the same as the sine and cosine. It's just your graph, it looks different. That's the only thing different here, okay? Alright, so these ones right here, since they are reciprocals, they're reciprocals of sine and cosine. So every place in which that, this one's cosine, every place in which cosine is equal to 0, because if you guys remember from the unit circle, cosine is x, and then secant is 1 over x, right?
Yes.
And we cannot divide by 0. We cannot have 0 in the denominator. So every place we have 1 over 0, that's going to be an asymptote. That's going to be an asymptote. So it's going to be undefined at those. So we're going to have that there. So this is what our graph is going to look like. So for this is secant. And I'm going to sketch what the cosine graph would look like. So the cosine graph would start here, go down to here, up, down, and there we go. So this is the graph of the cosine. Yes?
So would a negative cosine be the same as a positive secant?
No. Negative cosine. So the negative cosine would mean that, remember, cosine starts at the amplitude. So if it's a negative cosine, it would, instead of starting up here at 1, it would start at -1, and so it'd be like this. So it's still wrapped around the exact same thing, but it's the direction changes. Okay? So now, but these right here, so every place that this cosine is equal to 0, there's an asymptote. So I have an asymptote right here. I have an asymptote right here. I have an asymptote right here. And I have an asymptote right here. I think the best explanation for this is, it is the reciprocal, right? And if I flip over a wave, this is what's going to happen. So if it's undefined here, so from this piece right here, it's undefined here, I flip this over. This piece right here gets flipped over on the left, and so therefore, instead of going down like that one was, it's now going to be going up. So this piece right here now goes up here just to represent flipping that piece. This piece right here, in the next piece, in between my two asymptotes right here, so those, when I take those and flip those, that's where I get this.
Oh, okay.
Each one of these gets flipped. It's all part of the same graph. It's all part of the same graph. And so the same thing here. In between my two asymptotes,
When it has an asymptote, it becomes like that.
yeah, so in between my two asymptotes, I take my cosine graph and I flip it over.
Alright.
Okay, if you notice my cosine graph right here in the next one, I take that and I flip that over. My cosine graph right here for my last part, flip it over. Okay, that's the reciprocal of it. I flip it over. Okay, so let's take a look at... Okay, so now, like I said, it's exactly the same as the sine and cosine. So that means my period starts with what? 2 pi. Very good. 2 pi. This is the same thing for cosecant. So exact same thing that I was talking about. Wah 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 wah. There we go. I'm going to example 1. Because we've already done all of this. All this stuff we've done. So everything I'm going to tell you, it's going to be the exact same thing as what we did on 4.2. So, now, step 1. Amplitude. So I'm going to put a 1 here, and that's going to be my amp. My amplitude is what?
1, right?
Nope, try again.
2.
2. Amplitude is 2 because it's going to be the number in front, right? Okay.
Yes.
Step 2 is period. 2 pi over 1/2. Very good. That's over my b, right? In this case right here, b is 1/2. I heard some what's? Yes, we get 4 pi, right? I get 4 pi because I multiply by the reciprocal. Step 3. Phase shift. What is my phase shift? I say none. Step 4. My vertical shift. Do I have a vertical shift?
No.
So I say
None.
none. Remember, vertical shift is usually a number in front of this that's adding or subtracting to my secant. So, step 5. This one's what?
Parts.
Parts. No, because these tangent, cotangent, I have my asymptotes that I have to work with. These ones I don't. It's exactly the same. Okay? So this one is going to go straight to on step 5. I have my parts. Okay, so we have parts there. So now, if you remember 4.2, where's my first part? 0. I start with 0. So it's going to be 0, 1/4,
Fourth.
1/2,
3/4. 1.
and 1. And that 1 represents what? 1
Period.
period. Very good. 1 period. And so if I wanted to go 2 periods, I have to keep going all the way down to 2, right?
Yes.
Okay. I multiply this by, so these are my parts,
4 pi, right?
4 pi.
times period. And then minus my phase shift. So I don't have a phase shift on this one, do I? Okay, so it's going to be, my period is 4 pi,
So 0.
and then plus, or minus 0, right?
Yes.
So if it's minus 0, do I even need to say anything about that?
No.
But I'm hoping you will write this into your notes, because in first hour, a lot of people did not write this down right here. Parts, period, minus phase shift. Okay? You have to have that written down. Otherwise, when you come to us later, you're going to say, what do I do next? Okay, I'm telling you what it is.
Parts.
Yes?
So it's parts
Time.
times period minus phase.
Thank you. Parts times period minus phase shift.
What about the vertical shift?
What a what?
The vertical shift.
Vertical shift only moves it up and down. It has nothing. These are my left and rights.
You only use vertical shift when you're graphing, right?
Yes. Vertical shift is only when I graph, just like my amplitude is only when I graph.
And the phase shift is, where'd you get it from? Like, or where did you see there was?
Yeah, what do you find it?
See this phase shift?
Isn't it in
It would be,
parentheses?
yeah.
Okay, so now, is this have a parentheses?
No.
So inside the parentheses, that would be moving left and right.
Okay.
This one doesn't have it.
Okay.
And then
We-
vertical shift?
And vertical shift would be a 1 or something plus this function.
All right.
Okay, that's my vertical shift, but we don't have one there.
All right.
All right, so let's do our math here.
0.
Okay, times 4 pi times 4 pi. So my first one here is
0.
0. Second one,
5.
third,
2 pi.
fourth,
3 pi.
last.
4 pi.
So how many periods am I graphing this over?
1.
This is all over just one period, isn't it?
Yes.
We should have more like this. It's always 5 parts.
What's what?
Yes, it is. Okay.
Okay. So here's my 2. So let's go ahead and I'm going to set up my graph. So from my graph. So I have 0,
1/4.
pi, right?
Yeah.
2 pi, 3 pi, and 4 pi.
Yeah.
Now, my amplitude is what?
2
So it goes up 2
down 2.
and down 2. Now, secant is the reciprocal of what?
Cosine. Sine.
Cosine.
Cosine. It is cosine. Secant is reciprocal of cosine. So cosine always starts at the amplitude. So my amplitude is 2, right?
Yeah.
So I'm going to start by graphing the cosine function. So my cosine, so I'm going to do 2 cosine of 1/2 x. And I'm going to have it in blue right here for my notes. So it's going to go here, start here, hit 0, keep going, go down to -2, to 0, and right here. So it should look like this.
Your cosine, right? So that means your secant will be opposite.
Yes.
What do you mean?
This is the cosine graph. Okay, so now that I have my cosine graph, I'm going to go through and I'm going to asymptotes. So, where's my asymptotes? Where did I say my asymptotes should be? At 0, right? When it's going to be 0, it's on the x-axis, right? So I have an asymptote at pi and very good, pi and 3 pi.
Oh, so when it crosses, basically.
Yep. There we go. So I have my asymptotes there. Okay, see where it's 0? So where cosine is equal to 0, and that's the axis right here, right? Where cosine is equal to 0, that's going to be an asymptote because secant is 1 over cosine, right? And 1 over 0 is undefined. Okay, I can't have 0 in the denominator, so that's undefined. And so that's where I get my asymptotes at.
It's gonna be like that every time that it's secant?
Every time it's secant. Okay, and sine, cosecant similar. Cosecant, so every place that's going to be equal to 0, you're going to get asymptotes. Alright, so now I'm going to graph. This one is actually going to be the graph of this now. This is the graph of it. So now for this, I'm going to do it in black. So now, this piece right here, in between my start and my first asymptote, I want the reciprocal of that. So I'm going to take this and I'm going to flip it. So if I flip it, it starts here and it goes like that. Just
What?
this little piece in blue,
Oh.
I'm going to take it and flip it over, right?
So
Okay.
it's flipping everything.
Exactly. Now,
So this will go down.
this one in between here, these two. So these two, in between my pi and 3 pi,
Go up.
is it going to go up?
Go down.
It's going to go down because this is already going up, isn't it?
Yeah.
This is concave up, so therefore it's going to go down. So we have that.
Oh.
And from 3 pi to 4 pi, it's going to go up, isn't it? So it's going to go here and it's going to go up like this. Easy?
Easy.
If you notice, the graphing part is the hardest part because that's where the changes come in. Everything else is exactly the same. So we graphed the cosine, then we did our asymptotes, and then I graphed my function. So my function's in black. That's the one I have to have.
Yeah.
You can get away with not doing this, the blue one. You need your asymptotes, and you need to have your function of the black.
You don't do the middle?
You don't have to. You don't have to. I graphed the middle so I could see how to do this one. I did because the blue one is cosine, and I want the reciprocal of that. So that's why I took this and then I flipped it.
So, if, like, on our homework, are we gonna have to draw out graphs and stuff?
Yes, you are going to have to graph on these.
So is it okay, so would we have to use 2 different colors for our cosine and our...
You don't have to. You don't have to, but these are the pieces I'm going to be looking for. Yes? Okay. So let's try another one then.
Is it gonna be?
So here's what their graph looks like. It's nice and pretty, isn't it? So they did it over multiple periods, but it's the exact same. Since I started here, I started at 0 and I went to 4 pi. So mine's here, down, and up. Right? Okay. So let's take a look at the next one. Okay, step by step. Every single step. Step 1, amplitude.
Yeah.
So what would it be?
Yes.
So,
Step 2. Go ahead, Rocha.
so that means that there's no vertical shift,
There is no vertical shift.
but there is phase shift,
There will be a phase shift.
which is negative pi over 2.
It's going to be as soon as I get there.
Yeah, yeah.
Okay. All right. So period.
2 pi over, it's just
2 pi over 1, right? My b value right here.
That's 1.
B is 1, right? So emphasizing the b being 1 here because when I do my phase shift next, it's going to be this divided by b, right?
Yeah.
My phase shift is this divided by b. So step 3. My yes. So the phase shift is going to be what?
Negative pi over
Huh?
Yes, the phase shift is going to be negative pi over 2.
Well, how'd you get that?
Now, see right there where I circled where it says x minus pi over 2.
Yes.
Because this piece right here, the minus pi over 2, you take that number and divide it by b.
But B is 1, so it's.
b is 1, so it's just negative pi over 2.
Yeah.
Does that make sense?
Like
So if there was a b, say b was 2, you would do.
Negative pi over 2 divided by 2.
Yeah.
Yes. Okay, so you would have to divide that out.
Okay.
So now my phase shift is negative pi over 2. My vertical shift,
None.
none.
Parts.
Okay, step 5, my parts.
0.
So 0, 1/4, 1/2, 3/4, and 1. So every time it's my parts.
Times period. minus
Period.
phase shift.
Minus phase shift. So my period here is
2
2
pi
pi.
over 1.
2 pi minus my phase shift, which is,
Pi over 2.
Parentheses negative pi over 2.
very good, negative pi over 2. All right? Yes, it is a lot of work. It is a lot of steps. But if you take it step by step, you will be fine for the whole thing. All the steps. Okay, let's go through. This is going to give me what?
Negative pi over 2.
Positive pi over 2. So, it's going to be 1/4 times 2 pi is pi over 2, right?
Yeah.
Yeah.
So it's going to be pi over 2
Okay.
plus pi over 2.
You got 2 pi over 4. Pi over 2.
Isn't that pi over 2?
Okay, so now,
So it's just pi.
okay, with Dia de Pablo coming up here, if you got half a pi and you add another half a pi, you end up with
Pi.
1 pi, right? Half plus half is
It's simpler when
1
you
whole.
say it.
When we say what?
It's simpler when you
Yeah, Yeah,
say that
because
there's half a pi.
if I would have known, I would have been like, okay, 2 pi.
Oh, okay.
Oh,
All right. So if you think of it in terms of food, then you're like, oh yeah,
That's what it's bro.
I know, food is life.
Quick, come on, you have my attention.
Let's. All right. So this is gonna give me what? Pi. So it's pi, right?
Yes.
Pi
Plus
plus pi over 2. Remember, the pi's over 1, isn't it?
Yeah.
So they're different denominators, so I'm going to do the cross. Or the butterfly, or...
3 pi over 2.
The bow.
Yeah, the bow. So it's 2 pi plus pi over 2, which is
3 pi over 2.
Butterfly.
3 pi over 2.
Oh, yeah.
Okay, who said hold on what? Okay. All right, so we have a whole pi, and we add half a pi. So we got that whole pumpkin right here, and we add half of a pecan. So you have a pi and a half, right? 1 and 1/2 pies. So 3 pi over 2. Anyway, I guess the food joke kind of ran out. All right, so this one's going to give me what?
6 pi over 4.
6 pi over 4, which reduces to
3 pi over 2.
3 pi over 2 plus pi over 2. 2 pi, right? Okay, so common denominator, so I add, so it's 2 pi. My last thing, so it's 2 pi plus pi over 2. I'll let you guys do the math on that one.
5 pi over 2.
5 pi over 2.
I think it's not
Jake,
What?
you want me to do the math?
Please.
Okay, so 2 times 2 is 4 pi. 1
Oh, that's,
plus 1 pi, right?
mm-hmm.
Over 1 times 2. There we go. So we get 5 pi over 2. Does that make sense now? Okay, so now I'm going to go through and graph it. I have all my parts. So I start off with pi over 2, end with 5 pi over 2. Yes? Are my increments right? Say yes.
Yes.
No? Okay, so what is my amplitude?
I mean, 3 over 2.
3 over 2. So it's going to be 1.5, right? So it's, here's 1, here's 2. So it's right in between, so it's 3 over 2. It's 1.5.
What?
It's 1 and 1/2, right?
Yeah.
Yes?
Yeah.
Okay, so 1 and 1/2, it should be right in between there. Now, in blue, so my thing was, so if this is cosecant, I'm going to graph secant. I'm sorry, cosecant, I'm going to graph sine. So it's going to be 3 over 2 sine of x minus pi over 2, right? Okay, so I'm going to do it in blue. So you guys see it. I label it in blue right here so you can see. So now, where is sine always start at?
0.
0. You guys agree? Sine always starts at 0, right? Brittany?
Right.
Yes. So sine always starts at 0. So now, if my first increment is at pi over 2, that one's going to be right here at 0, right? Yes?
Yeah.
Is it a positive or negative?
Positive.
Positive, so it's going to go up. So up here, it's going to go up to 3 over 2. So it's going to go up to 3 over 2. Then over here, the next, it goes down to 0.
Okay.
Yes.
Maybe better.
Go ahead. And then after 3 over 2, it goes to negative 3 over 2. Back up to 0. So that is a graph of the sine wave. Yes? Okay, that's a graph of the sine wave. So after you graph the sine wave, what goes next?
The asymptote.
So every place in which that it's equal to 0, that's my asymptote. So I'm going to start off with an asymptote.
At pi over 2.
Where's my next one?
3 pi over 2. And 5 pi over 2.
And 5 pi over 2. Right?
So for cosine, is it always going to be 2, and for sine, is it always going to be 3?
I'm not going to say always. It just depends. Depends on what your intervals are and all that other stuff. So if it said 2 periods, you're going to have a bunch of them. So
Okay, but
so every place it's equal to 0 at.
so when there's vertical shift, where are the asymptotes?
Okay, if there's a vertical shift, so if I'm moving this whole thing up, so just think of it and slide the whole thing up. Does that change my asymptotes?
Yeah.
No.
No. Okay, so if there was a vertical shift that was 2, okay, I would move the whole thing up to 2. And at 2, I would draw my dotted line. So it's going to wrap around that dotted line. So every time this thing right here, so this is going to be it's still my 0, but it's 0 plus 2. So it's going to be that spot. This is also still going to be 0. 0 plus 2.
Basically, wherever the graph intersects the axis, they wrap around.
Yes.
Is an asymptote.
Yes.
That's where zero.
Yes, and that's what we're looking for.
Okay.
And so if the vertical shift is going to move up, draw a dotted line, and so that's where it crosses that. Yes?
I get it.
Okay. All right, so now we have that. So we have our asymptotes and we have our things. So now it's time to actually graph our function. So now for our function, which is, what was the function? So it's going to be 3 over 2 CSC of x minus pi over 2. So now in between these asymptotes right here, this thing, I'm going to take it and do what?
Down goes up, right?
Flip it up, right? So that one's going to go up. Okay? In between these asymptotes right here,
Goes down.
flip it, it goes down. That's it. Easy? Maybe? Okay, I'm going to give you guys the rest of this time to try and work on this. Yeah, when it comes back. Alright, so don't forget, like and subscribe. Christian.
Don't forget to like and subscribe, comment, share with your friends, pass the test.
And do your homework.
Do your homework.
Subscribe. Put on that notification
Put
bell.
dates on your homework so Pasha doesn't turn in as late.
And if you want to get credit, make sure you put your name on it.
And if you want to follow me